I've asked it to start. Oh, it started. Well done. Well done, computer. Oh, how nice. Okay, I can see chat from here, can't I? I can also see chat from here, can't I? There we go. There's chat. Let's see if I can find out what time it is by putting something in chat. Oh, telephone's telling me I've gone live. I don't know where I've just been typing, but God knows what happened. Let's try that one. That looks okay. Rightio, we're up and we're live. My name's Fraser Sharp, and today we're looking at C, the programming language. Okay. And it's 12:30. Ooh, so I'm starting early today. My God, what's wrong with me? Okay, on the screen, can we read it? That's the first test. Do we need that any bigger? Control plus. What's the next size up? Let's find out. That's a little bit too big, I feel. Okay. Lovely. I don't know why it's doing this. Stuff it, I don't care. Does it build? Oh, my Twitch export to YouTube succeeded. Oh, that's gone to my Fraser Sharp YouTube thingy. I think there's a link in the video. Well, there should be a link in my thing below. On the page, anyway. Don't know if there is or not. You have to go to a different part of the page these days. It's all gone to pot Twitch. They have different pages. What have we got here? Terminal. Run build task. Yeah, that's fine. So these errors is just Microsoft being stupid again. Thank you, Microsoft. You're ace. As ever, you can always trust Microsoft. Right, got a cup of coffee, and yeah, I'm programming in C today. We might go on to program in C++, but I think we should start back at the beginning with C. In yesterday's live stream, we were going through different things in Rust, and I've decided against developing in Rust as a permanent thing. Not because I don't like the language, I love it, but because it has different problems that we can't really have for streaming. We need immediate. I can't accept a compilation time of over 10 seconds. That's a base rule. I refuse to. If it takes more than 10 seconds to compile, it gets thrown away. It means I've programmed it wrong, but in Rust it doesn't. So they need to develop that language a bit more before I start using it mainstream. Especially on the compiler side, because it does compile into C. Well, into machine code just the same way as C does. It is basically C under the hood. So, I mean, it was developed in C, should I say. Very good language. Awesome. Rust, check it out. Try it out. Have fun with it. Brilliant language. To me, it's the language of the future. If they could iron out I'm going to call it library bloat. Right, that's enough about Rust. C has the same problem. C++ has the same problem, but at least with these ones I'm in control of it, not the program, not the actual C or C++, where Rust is. It's a full development environment. Project goal for today, how to read a text file. This is what we ended up with yesterday on yesterday's stream. So we're just going to run through how to set up. Well, use whatever you want to run your C. I'm going to use a text editor called Microsoft Code, which unfortunately comes with Microsoft IntelliSense. Yeah, Microsoft IntelliSense, folks. It's here. It's to stay. It's rubbish. But we use it anyway, because it's for C and C++. I've also included the Qt for Python, because I am using a Qt for my build environment. So I use a profile, a Qt profile. That looks something like this. What I didn't do yesterday was add in the config for the debug, so we didn't have any debug available to us. Today we have, because I've included it. I haven't been an idiot. I've also added from yesterday, obviously, my details. So this was on yesterday was the 10th of July 2020, and this is the configuration file we ended up with. That was given to us. We use Qt Creator to make this. Yeah, use that thing there, Qt Creator, download it, and use it to initialize your file. In other words, you press new and you make a file. So, for example, I can press new. I can press a library, for instance. It says C++ library, but C as well. Come on, I'll use this. Choose, I'll call it sandbox underscore lib. I'll put it in my projects, use its default. Build system QMake, which is a build system I'm using for everything on here, because it's easy to use. Shared library. No, statically linked, please, for development. Shared library after you developed it. Qt module cure core. Yeah, that'll do for now. I'll take it off. Header file. Yeah, that's okay. Next. Don't want any translations. Make sure it's using build. Yes, it is. Add to version control. Git. There we go. Finish. And there we go. We now have a created sandbox library. Which I will be using later on. What I'm also going to do at this point is, on my welcome page, I've still got the sandbox thingy. I'm going to come into here. Can I just release it from Microsoft Code, please? Sandbox Pro. Okay. Take that off as well. So this isn't on the same programs, so I can alter the files. In Sandbox here, I'm going to right click and I'm going to add a library to it. External library. So I've just made it. Next. Wait a minute, cancel. Can't do it. Where's the library itself? Can we just get some space here? I can't see what I'm doing. Better build that. You have to build it before you can link it. Okay, that's done. Alright, so in the Sandbox Master, add a library. Very complicated stuff. Not. Let's be honest. So, I'm on Linux. Browse. It's under Projects. Library in the build directory. It's there. Because that's what I've just done. Just built it. Open that. That'll place that in there. But the include path, I don't want it to build to the build directory. I just want to take it one directory up. There. That'll do. That'll be the include path. I'll just have Linux, library, static. It knows what to do. Next. It tells me it's going to add this to my sandbox.profile. So I'll click finish. It has done. There we go. Save all. And yeah, I can come out of there now. So here we go. My sandbox profile now has include path, depend path for my sandbox library. It has everything there. Only trouble is I can't see it. This is where the power of imagination comes in. Because what we can do is close that and close this. Close folder. There we go. Ah, and it did that. Lovely. Thank you, code. I'm going to get annoyed at this, aren't I? Close editor. Close folder. Thank you. That's what I wanted to see. So instead of opening a folder, I want to add workspace folder. Okay. Slightly different. It's in projects. And I want sandbox. So we're going to add sandbox to our workspace, which is untitled at the moment. Now I get the option add folder to workspace, which I can do now with a standard lib. And now look at what we've got. We've now got two projects. And now I can save my workspace as a project. I'll put it in here. Name. Oh, I'll just call it Sandbox Workspace, can't I? There we go. Save that out. And now you can see up here, it's come to Sandbox Workspace. Yeah, lovely. Now, we can't build this from here at the moment. So what I'm going to do is I'm going to make a copy of this. And we'll go through this today on how to make this buildable. So copy that into here. Paste. And let's start at the CPP property, shall we? This is the first JSON file. I should have shown you how to create them, shouldn't I? It's in the manual on the website, Microsoft website for VS Code. So if you need to know anything, just go and look it up. Or ask in chat and I'll show you how to do it. That's better. come and chat with me, ask me how to do something, and I'll show you how it gets set up. So the path, Linux, configuration, name Linux, yes. The path, yes. Defines compiler path, C standard, yeah, I'm happy with that. C++ standard, I'm happy with all of that actually. I'll agree with that one. I don't want the launch, I want the tasks next. No. So I'm going to call this build lib. Because I'm only going to have these two files. We're going to use build sh as before. That's our source. So that's in build. We don't have a build sh. Okay, that's easy enough. Copy that. We do now. Build sh looks like that. Changes directory, uses qmake and then make. Lovely. So that works. Args none. Current working directory is workspace folder, yeah. Problem matcher, kind build, yeah, that's fine. We cannot launch. We can't use this because you can't launch a library. Delete. Yeah, move to trash, I don't care what you do with it. So we can build it. Terminal, run build task. Now comes up with two options. We have sandbox and sandbox lib. There you go, nothing to do. The library's built. Fantastic. Thank you. This now means that I can have a library. Well, this library is now attached to here. So, what does that mean? It means I can use this to store items in a header. But there's a secondary problem that I've just introduced, and it comes into VS Code now here. Because I don't have the include directory for it. So, we better add that. I don't think, no, it won't do it automatically. It's IntelliSense, isn't it? It doesn't do anything automatically. So it's going to be a dot. No, it's not. Careful. It's $, open brackets. This is Microsoft we're talking about. Treat it like it doesn't know anything, because it doesn't. Workspace folder. Close the brackets. So we will have to use ... Actually, I don't think we need to do the workspace folder. I'm just going to use ... because we've got a CWD, haven't we, going on? Not in here, we haven't. Okay. ... and we want to go into sandbox lib. Sandbox _ lib. That will do. Yeah. I'm just trying to think which directory I want to go into after that. because I want to store everything somewhere in sandbox lib, I think. Right, that sets up my IntelliSense. Yeah, that'll do. I'm happy with that. In sandbox lib, I want a new folder. Now this is going to be tricky. What are we going to call it? We'll call it S. Yeah, we'll call it sand. Sandlib. No, we'll just call it sand. That sounds, yeah, that's funny as hell. So yeah, we'll have it, right. So it'll be in sand. In sand, I'll have a new folder, and we'll call it core. Okay. And in core, have a new file, and we will call it test.h, because I don't know what to call it. All right, there we go. Test.h doesn't really do anything, but anyway. Terminal. Run build task, build library. Done. Okay. Got 13 modifications now. Oh dear, what are all these modifications now? Main, sandbox, CPP. Okay, so we've got 4 in. Yeah, okay, I understand now. Yeah, that's alright. We'll sort that out in a minute. I want to make sure it works first. Okay, so I can just do that. Back in main, I should be able to now include that header file. Hash include sand. There it is. /core/ test.h. There it is. Magic. So now you can see that I can use a library which I can create myself. That's important. There's nothing in it yet, so that'll do. Delete. Bye. Righty-o. We're all up to date. So let's sort out this lot first. So sandbox git create. So we now have no, it's a static library. Static library sand. I should really put those in little diddy thingy marks, shouldn't I, to do it properly. Yeah, that'll do. Commit that. And over on the lib, looks okay to me. And that's just first commit. Tick. And update for use using MS Code. Tick. Right, that's everything. Good. Right, let's get on with today's lesson. Right, here we go. What have we got so far? We have a file. Project goal, how to read text files. And it goes something like this. We just print out a welcome. And then for each argument that's being passed in to main, from the command line, we print out what the command line argument is. I'll demonstrate that in a second. We then say press return to continue, and we get char. Get char is just reads a character from the standard in, which is a command line. So after hitting return, it then opens the file that we are in here called main.cpp for reading the R. It means that we are going to read it in. We then check if there's an error, in other words it can't find the file, and return an error code of 99. 99 you'll see me use all the time. That's my personal code that I've chosen. You can use any code that you like. It's just an easy number for me to type. Simple, really. And then we do a while loop. So while we are reading in the current line, so f get s current line up to 255 characters, we are going to read it into a variable called file, well, from file in. Okay, current line, there it is, char, current line, 255 characters. If it's not equal to null, in other words, something hasn't gone wrong or the end of file has not been reached, we just continue around this while loop. And that is, then we just print the current line back out to the console because we're not doing anything with it yet, but we will do today. And then after we're finished, we just close the file, just to tidy up. Simple. How powerful is that? Hey, Yusuf Raza, hiya. Good to see you, mate. No, I'm not Australian, I just did that on purpose. Yeah, so that's a very, very simple program, but it shows the power of C. With very, very few commands, we have access to the whole file system. And that's where C is brilliant. It's fantastic for this kind of thing where we are operating directly upon the computer's hardware. There you go. Yusuf, I don't know if you saw yesterday, but I did end up that stream doing this program. So this is the program I ended yesterday's stream with. Let's run it. So I do have a debug mode. I'm not going to use that. Just build it. So build sandbox. There we go, that's built. I'm going to run it from the command line. I can run it, I'll show you debug in a minute. So from the command line, can you see that? Let's just make sure that we can see that. Control. Ah, yeah, we can see that now. Yeah, we can see that. CD. Projects. And I want sandbox. Any questions you have? Oh, I know you're from the UK. I sold out. Ah, dear. If you want to repent to your Lord Jesus, fight this corrupt system. Join the Cyber Revolutionary Army. I think I did that 30, 40 years ago, mate. So I want to be in sandbox. Yeah, that'll do. I'll just be in sandbox itself. Okay, so there we go. and I want to run build sandbox. So, and I want to put some like this is a test. So this shows how powerful C is. Okay. So as you can see, it accepted this is a test as command line arguments. You'll think, why is that important? I'll tell you in a minute. I'll tell you now before I hit return. It's important because, one, when I run the program, I can talk to the program directly. I can use, like it says here, options. I can use all of these options. That's how it's done. So that's probably written in C, Pac-Man, or some kind of language like C. So yes, you can use all the command line arguments, and that's how it's done here. Very powerful, but there's one thing they don't tell you, and this is a big but. This is the biggest one ever. It means your programs can talk to each other. Think very carefully about what I just said. And it's something that we are going to be exploring, maybe later on, but not right now. It means that I can run from here, in this file, sandbox, I could run, say, Pac-Man. With any of the command line arguments I want. Which is why I was looking it up. I was thinking of doing that as a demonstration, but I don't want to show you how to do it. Because that's not what this is about. I'm not going to be building an operating system for you today, but C is used for building operating systems primarily. And then you usually build something upon C. But I'm going to show you something slightly different about C that people have missed over time and forgotten about. When we press return, if you remember, we are going to open file main, which is the file that we're using for programming. So they are press return to continue. It's now going to read a text file, which is main.cpp, this file, and it's going to output it printf to the console. So when I hit return, this file will go to the console. Okay? Return. And that's how powerful it is. Something you may note though, it's got the end of line character attached. Ooh. What happens if I click on that? Nothing. Okay. Just wondered. Interesting. Didn't know it did that. Hasn't come up with this one. I didn't put www dot in front of it, did I? So there you go. That is how powerful C is. We have very few lines of code. In fact, the lines of code that we do have are because I've been writing it downwards. Because that's the way I type. One command ends in a semicolon. That command can be placed all on one line. So we have 1, 2, 3, 4, 5. No, let's count them properly. 1, 2, 3, 4, 5, 6, 7, 8, 9 commands in the whole of main. Out of those 9 commands, we have used 1. They're in purple, by the way. Anything from C, except for that one, is either a type or a variable in purple. So I've got 1, 2, 3, 4, 5, 6, 7 commands for C. There's only 15 commands in C, and we've just used 1, 2, 3, 4. No, you don't count those. The commands are 1, 2, 3, 4. We've used 4 of the 15 commands. Yeah. Interesting. Types are int, character. I think those are the only 2 we've used. But that's an array. 255 characters in the array. That's how you nominate it to be an array. You put square brackets and a number in. It means there are 255 characters in the current line. Yeah, go figure. Up to that, because we're reading up to that. Yeah. Otherwise, very simple program. Any questions about C? Oh, what's the include? The include is called a library. Well, we just created our own. That's correct. We have now got our own library. Look, it's here. We can use our own library. But the standard library consists of these as one. No, there's not that much. All of these here. And we have used stdio, which I've pulled up here. And these are all the functions that you've got in stdio. You don't have to learn them all. Just look them up. So printf. We used a printf here with return carriage, return carriage. All that does is make 2 spaces going down. Or that's actually not, yeah, it is return. On Windows it isn't, it's new line. So we'll call it new line, alright. Because people on Windows it isn't. We've used %s so we can put an argument into our printf. It can be formatted. An S is a string of characters. There's a table here of things that you can use. Decimal integer, D or I. Oh, they've changed it. They've added I. Well, blow my socks off. Finally. Mind you, it has been a lot of years, hasn't it? So, 25 years. 35 years. 35 years. Holy. Yeah, this is bringing back. There's flags, precision for numbers, width. And there's a few examples of printf here for you. This is all at c++com reference, which is the reference documentation for C and C++. Anything you can do in C, you can do in C++. Anything that you can do in C++, not necessarily, you can't necessarily do it in C. So be careful which way around you're doing things. Or thinking about things. So yeah, that's printf. Just wanted to show you that there are different flags, and that's how it's used. Okay. Pop that back under our chat. So, onwards and upwards, what can we do with this? Well, we can do an awful lot. The first thing I would like to do is to remove the reader file into its own function. We're going to do something called refactoring, because then we can have a look at this function and see how good we can make it, how useful we can make this for ourselves, and we can design our own function. So let's do that. Lovely. Let's see, what shall we do? How shall we do this? Is this tricky? No. First thing you have to know about C. Int main is always at the bottom. It can't, a function cannot use anything that has not been declared yet. So if we are going to make a function, we're going to start by doing it here. It takes a type, a return type, in this case, we're going to use void because I don't want anything to be returned. What are we going to call the function? Let's use English. Call it read file. How's about read a text file? That's a bad way of doing it, actually. Do it. No. It's a function name, isn't it? It starts with a capital. Read a text file. Okay. We then need the open and close brackets, and then we have these thingies. I didn't pull that back up, did I? I'm going to have to get used to doing it this way. I don't usually. Okay. And in the body of this, we are going to take lines. Come on, mouse. Work. 47 to there. We are going to cut them out. Pop them in. There you go. All the instructions are now in read a text file. Return 99. Can't do that. So that's the first thing we have to notice is we have something here that is a return value which is now an error because we've got void. So all of a sudden that's no good to us. So we can print an error, but we're not stopping the program anymore. Where's exit? I'm sure we've got it. No, we haven't. How do we crash the program? I would prefer to be returning 99 anyway. We want to keep control of it. So to do that, what we are going to do is going to return false. And at the end, if we have succeeded, we're going to return true. Both now say, oh, we can't do that because it's got a void here. So we'll have to change that now to Boolean. Bool. There we go. That's that done. Save it. All the errors go away. And there we go. So read a text file is what, 1, 2, 3, 4, 5, 6, 7, 8 lines long. But I've typed it out in a few more lines so I can read it properly. Some people don't like the way I do it, but like this, I really should be doing this. There we go. That's better. Give it a bit of space. Don't be frightened to use space. But you'll see that every command will start with a command. It will operate on some kind of variables, and then the command finish is always with close bracket and for a function anyway, and a semicolon. And the lines going down will match. Okay, that's a command, printf. It's actually a function, but hey ho. So the end of each function. Now, if we run this, run, I've got it under the debug now. Can you bring up our terminal at least? Okay, if we run this now, return, nothing. It doesn't do anything, it just returns. Well, of course it doesn't do anything because we haven't used the function that we wrote. Let's get rid of those. Is there a shortcut for that? There's a Control-Shift-B for build. F5. Well, that's an easy one. So use key F5. Let's just test that out. F5. Oh, fantastic. Yeah, that works nicely. We'll use key F5. Hit return, nothing happens. Okay. Just close that. So we now have to use the function that we have created. So all we do is use the function that we have created. And now F5, it'll build it, and then it'll run it, and when we hit return, it works. We get our function being used to read the main.cpp file. That's really good, that. I like that. There we go. Awesome. Now, as you can see, main has now become smaller. What people would probably tend to do is to take this and put this into a second file and call it something like initialize application or something like that. I don't. I put this all in here because I usually take a lot of this out and I do mess around my initialization. So I'm going to put myself a note in that this is the initialization. And I'll just pop that straight across there. And now split up my main file into two parts. Well, it's going to be three parts actually. There we go. Lovely. So that's how I would write my main function. Other things that you should note, or literally note, is please, please, please comment everything. Nobody on this planet knows what reader text file does. They might be able to guess from its name, but they don't know what it does. So I would tab to about halfway across the screen. I put in 2 slashes for a comment, and I could read text file and output to console. You see, this is the whole point. We are going to need to bring that out back in a bit, aren't we? That'll do. Okay, it's only because I'm limited on space on the screen. Normally I'd have full screen up and stuff like that, and it wouldn't be this big. And there we go. That is now correct as far as I'm concerned. Because it now, everything that is C, I'm not going to note because people can look it up. It's all here. in the reference manual, so everybody can look up how to use printf and get char, but nobody can look up how to read a text file. You can't Google that, so you have to give us a hint, at least tell us something about it. Okay, and what you would find is people will go as far as doing, I don't know if it does it on here, pling, nothing, nothing, is it a star, nothing, no, we haven't got anything installed then. We've got no documentation thing installed on here. That's fine, it's a text editor, who cares, not my problem. So everything's manual, that's fine. Now, debugging, how does that work? Well, on a to debug this, what we can do is we could print well, we'll start here. Line 65, printf, welcome to the blah de blah. If I now press F5, okay, it's running the program, but as you can see, there's no output. But there's a thing there, print line. This indicates the next line that is to be executed. It hasn't executed that yet. It tells me that those are the arguments in the local area. There we go. It's just a slash. It's just a character. Okay, it tells us all of this. Our breakpoints are down here at the bottom. So it tells us that we've got one breakpoint in. That's a bit far down. And this is the call stack. This tells us that that's the function we're in. That's going to change. So up at the top though, we have step. We can step into and out of. So we can step into a function and out of a function. We can also restart the program. Okay, or we can continue it from there. What I'm going to do is I'm going to step over. So step over. Okay, it's now going to go into this for loop. Welcome to the sandbox. Okay, let's just stop at the next printf. You see it comes up here. So we'll just continue. There you go, it's gone through the for loop. Command line argument equals blah blah blah. And there's your command line argument. It's an address that it's looked it up from. It has 47 characters in it, starting with a slash. So if you counted how many letters and characters were in there, there's 47, and it starts with a slash. There you go, that's what that tells me there. I don't think I can actually get any further with that, can I? No, I can't. Fair enough. Now, printf return to continue. So that's the next command. Let's step over that. There you go. Press return to continue. It won't work. The next line hasn't been executed yet. When I do that, yeah, it's taken the return value and it's stored it in a buffer and it's used it. That's good news. Thank God for that. Now we're here. It's going to execute our read text file function. So I'll step into it. There you go. Read a text file. You can step through this. Opens a file. Decides that it's not null. And then let's print it all out. So continue to the next one. See how we can block its execution. There isn't a to cursor on this one. It's usually better with a to cursor, but anyway. So it's now printed it all out, got to the end of the file, and close it. Continue, continue. And there we go. Return 0, end of execution. Right. Let me just put a breakpoint there. Restart it. Alright, so continue, 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 hit return, continue, step into, just want to go into here, look at what happened to your call stack. The function that we are currently in goes to the top, but it tells me, the call stack, that it was called from main, which was called from the system, and it doesn't put the system files in here, unfortunately. But watch what happens if we just rerun it a minute, and I step into printf. It didn't work. Why didn't it work? Because it's not one of our functions, is the answer. Which is a disadvantage, but not too big a disadvantage, I guess. Can we clear all these? Okay, just remove. 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 Tidy up. Just remove them all. But that shows you all about how you can debug your program. Because whilst you're in that debug mode, let's say I wasn't happy. I didn't know if this was being called or not, or what was happening here, whether it was an error. I could go to here and find out what the heck's going on by querying these variables, finding what's going on here. But there's no real variables in this, is there? It's just that current line. We didn't set it to anything there. Yeah, that's a good line to stop at. What do you want, Muppet? What's wrong? Muppet's one of my cats, don't worry. He's just interrupting. So let's just do that one. F5, please. Hit return. There we go. So current line comes up as one of the variables. And as you can see, this is what it contains. But it's just a load of numbers, Bladez. Yes, that's right. That's what it contains. So if we step over that print line, and we keep going, there we go, /star. So this will now contain /star, /star. Alright, that's what it prints out. And it does have the return end character on it. That's fantastic. That's a null character, so that's end of line. Or end of string. That's the end of string character. That's fantastic. So you can actually have a look at your variables. File in is just a number. It's actually an offset, that, in memory from where we are in main. From the start of our program. That's interesting. That's how C works. But anyway, that's a whole different story. Right, I'm happy with that. Sandbox. Yeah. So we can see that we have added there we go. This is what we've got on the right hand side. And this is what we did. Okay, so message. Our first function. Now, there is still a problem with our program. And that is we have not, and this is a big problem, which people tend to miss. If you remember, I was umming and ahhing about this return false and return true. What this means, it's now a Boolean value that we get back. We have two ways of looking at this. We could make bool success equals that. That's correct. Or we can call an if statement on it, which would be better in this. So this whole function returns a Boolean value, true or false. So if it's true, then we're okay. If it's false or not true, so no, I'll do it the proper way, because I prefer doing the proper way as well. If that is equal to, the logical equal to false, for instance, what we can do is delete that, and we can return 99, because we couldn't return it before. So there you go, that's where my return 99 goes to. And my notes are still there, so I'm happy about that. Yeah, that'll do. Yeah. And that's the original program complete. So if our reader, so you can see we've included some functionality now into our function, and we can use it properly, because I know that's an error. What did we have before? We actually printed out an error as well, didn't we? But we're printing it there. We now don't need this. All we need, we can cut that out. We don't need that anymore in here. Okay. We can place that in here. That's a better place to put it, I think, because it comes with the reading of the false. So that is an obvious error check. So this is what is known in the trade as error checking. Okay. Might not be obvious to you, but it's an error check. We are saying if it's true, ignore and just carry on. If it's false, tell us it's false, but get out of the program, returning 99 through there and telling us it was a cock-up. The next thing we want to look at, hold on a minute, but this function only reads that. So, what would happen if I wanted that to be generic? And this is where the interesting thing about functions comes in. And as we saw here, we had these arguments that were being passed in, and we were looking at those arguments. And we could have made decisions on them, and we could have programmed to do something depending on whatever decision we made. Interesting stuff. Right. And I think really that's the whole of C. We'll do the last bit then. We'll try and make it so that it's a generic string. But I still want it to be the same file, because I'm not really bothered what file we use. We could take the file name from the command line if you want. Just wondering if we should do that. No. I don't want to go into that, no. Let's see, how do you make a string? Char star file underscore name equals main.cpp. Now, why would that be any good to us? What would happen if I could take that and place it in there? Interesting. Well, we can't, it's an error. Too many arguments in function call. Well, we can change our function. It's our function, we can do what the hell we like. So I will make it into a constant here. Const char star. Why have I made it into a constant? I've introduced another word in C. Because we don't want to change it. And that's just going to be... we'll call it file. Yep. I'll do. There you go. See if that works, because now we've got the file being sent in. And we've decided, see, it's more complicated now. We could have asked the user for the file name, but no, I'm just making it main.cpp because it's easier for examples. F5. We got a warning. Interestingly. Press return. Press return. Press return. No, there's something wrong. So we'll have to stop the program. It stores them all up. That's funny. ISO C++ forbids converting a string constant to char star. Interesting. So it doesn't like the way I've used char star. That's clever. So we'll go to the manual and find out why. Size T, no. I don't need to start using that kind of rubbish. That's C++ though. It is const char star file name. Ah. I wonder if it wants its brackets. I wonder. I just want to do a build. Oh, right. I wonder if that'll work. And we just use and. I'll tell you why in a minute. That could work. Run build task. It's permissive. Invalid conversion of const char star to char. That's what I thought. Damn sure I got it right in the first place, you know. Alright, so warning. And it's a C++ warning. Converting a string constant to char. Alright. Make that a constant. Ta-da! There you go. It's because I've used const. Yeah, that all const means is that this cannot be altered. I can't now take file name and make it equal to something else. I can't change the contents of file name. So that is now the correct code for what we have written. Yeah, because that's a string. It puts a string notation ending on. Yeah, that's correct. Wow. That's actually what I wanted. I wanted to introduce you to const and what it means. So that is now the correct thing. We are passing in our file name and we are using our file name in here. For instance, if I do that and F5, okay. Turn to continue. Error, unable to read the file specified. And it should give me a oh, we don't print it out, do we? But it does put the error up. That's okay then. I'm happy with that. Put that to .cpp. Okay, return to continue. I hate it when it does this to me. Did it actually save? No idea. Okay. Run with debug. It builds. We hit return. And we've still got a thingy going. Okay. Remove breakpoint. Thank you for that. Continue. And it works. Still had a breakpoint up. Silly me. Lovely. F5. Just to show you it working. Welcome to the sandbox to see command line argument that was sent in. That is always command line argument 0 is always the command that was used to start the program. That is a guarantee. Press return. And that quickly, everything's there in front of you. There we go. Magic. That works for me. As happy. Now, what happens if we don't want to print it out to the console and we want to store it? Now we've got problems. What can we use? What we got? Assert C-type. Floats limits local math. No, I don't want it in math. Standard def. Could be. We're not using string.h. Interesting. What I wonder what we'll get. What would happen if we take this out? No, not yet. We'll leave that in for a second because we don't need to take it out yet. If we create a character string, I'm not comfortable with what I'm thinking. Let's go the naive way. Let's build it from basics. So char star, and then we'll have a look at what I was thinking. And we'll just call it we'll call it file red. And instead of printing it out, what I would like to do is file red equals file red plus current line. That's what I want to do. What is current line? It's a char. Cannot be assigned to an entity of type char. Oh god, fathers. Expression must have an integral or unscoped enum type. Unscoped or enum type. No. Okay. If I remember, put 0 on it. It's the contents I want. That's the contents of the very first character. Not sure about that. Is there anything we can do with current line? No. No, nothing. Okay, if I remember rightly then, it's going to be file red. Let's try that again. Delete that. Get rid of all of this. It's not that. We have to do an operation on it. Put char. Put s. Alright, let's have a look at what we've got then. Now thought through it. Write string to std out. No, I didn't want that. That was the same as that printf I did. Write string to stream. No. Oh, fscanf and printf. Ooh. Read formatted data from stream into variable argument list. Nice. So we take the file, the const char star format, and a list of arguments. Okay. File list args. As long as it's not read stuff. Well, that's a nice way of putting it. That's what we're doing. I have read $, string, yeah, and d, val d, close. Oh, I remember this stuff. Oh, God. This is going to be fun. There is an easier one. F. That's vscanf, isn't it? Does it have a return? Int vscanf, blah, blah, blah. Yeah. It's not really giving me return value. On success, the function returns the number of items of the argument list successfully filled. Okay. I don't think I want that. There's fscanf. Reads data from the stream and stores them according to the parameter format. Right, okay. Helps if I add that. Into the locations pointed by the additional arguments. Well, const char star format is %s. Let's see how they do it. A string of characters, yeah. %f, %s, 3.15 pi. Where are they going to store it? Mm-hmm. I need to keep going around it though. I need to put it into some kind of vector. And I'm not seeing vectors being mentioned. Interesting stuff. So, don't reinvent the wheel. See how to read a text file into I don't want to go into a struct. Into buffer sounds fun. I think I like the into buffer idea. String array is what I was hoping for. I don't care about your cookies. Stop asking me. They're describing the size of it. Line string length line I++, okay. F name. Yeah, you're pre-specifying though. That's the problem. I don't know how long the file is, so you can't use that. Okay. Let's try into buffer. Let's try that one. Declare the file pointer, yeah. And a buffer of characters. Char star buffer. Okay. Open the existing file for reading. Yeah. Quit if it doesn't exist. Yeah, we've already done that kind of thing. Get the number of bytes. Right. Right, so you're actually creating the buffer size. Copy all the text into the buffer. Once the buffer has been filled with a copy of the text from the source file, it can be used for operations such data extraction, searching, replacing, and outputting to another file. More about that later. Yeah, right, okay. Yeah. I'm seeing more possibilities with this version of it, but I'm not sure about grabbing memory. Well, that makes sense. Okay. Let's have a look at that, how that would look like to us. So we've got the file name. We have file in. So we would need to fseek get number of bytes. Alright, so that's the null check. Okay. Let's create a buffer. Alrighty. Let's give myself some working space with this. No, I think because we can use this while loop, I think. So what it's saying is create a buffer. So we're just going to create char star buffer, because why not? Well, that's what we're going to make it. If you want to know what a char star of, it's a byte. That's all it is. So we'll have that. Get the number of bytes. So we want to fseek, use the fseek function. The file stream is file in. Long off. Zero L. Zero long. Well, yeah, it's long. Alright, we'll try it. Seek end, which is one of these, yeah. Which is a hash define. That should work. We'll need a long. Long is an integer, a 64-bit integer value. We'll just call it file length. Bytes. Storage buffer in bytes. Got to make sure I know what it's in. we don't, we could be in trouble. And we need a semicolon to end that command. Alright. And I'm going to separate this off because I can't read it otherwise. Right, I want to look up fseek. What I'm going to do is I'm going to be looking up that command after to make sure I understand it properly. Oh, wait a minute, it says it here. Function is a possible cancellation point, yeah. I want to know what that middle variable does. That one that we put a 0 in. Okay. So, now our file length will equal ftel, open brackets. Ah, right, yes, I understand. I know what we've done now. It's a simple way of doing it, I suppose. And file in. There we go. Right, I'm happy with that. What we've done is we've asked the pointer, when you open a file, it generates a pointer to the beginning of the file. That's what C does. What we're telling that pointer to do is go to the end of the file. That will move your pointer to the end of the file. Then what we're going to do is ask the pointer how far into the file it is pointing, which is the end. And that, of course, will be the length of the file in bytes. So yeah. In bytes. Make sure we're still in bytes. That's a big key to this. We're doing byte-wise operations, not bit, but byte. 64 bits, bit operations. I'll probably be doing 32-bit operations really behind the scenes, I don't know. Haven't checked, don't care. Now what we need to do is get the memory. So let's get our buffer. And we are going to make that into a char. Cast it to a char star. I don't know if this is legal anymore or not, but we'll soon find out. So that's a cast. And we are going to use calloc, which we don't have. And it's going to be, right, where's calloc? You just got hash include stdio.h. Where you got seek alloc from? Because it's not in here. Calloc. Memory. I don't see memory in this lot. Okay. There's its reference. It's in standard lib. There. So let's get that in. STD. And it's just LIB, isn't it? Yeah, there it is. Now we can do it. Okay. C alloc, there it is. Got to be careful with these things. I want to keep that one up now. So we're going to allocate the number of bytes to the size of character here. So that's a file length, which we've just discovered in bytes. That one to the size of, and that's char, which is a byte. Size of a char is 1 byte, so we're just using file length in bytes. That's what we're really asking for there. And it hasn't come up as a warning yet. Okay. Fine. There we go. That's how I would write it. Yeah, we'll go from here. File length, amount of memory, and then here just ask for in bytes. There we go. So allocates memory, file length amount in bytes. Yeah, that roughly explains that, but I'm going to check it, make sure I'm right. So let's have a look at some of this stuff now. Now we've got the right buffer. We check if the buffer equals null. Why? Can that actually fail? Throw, yes it can. Alright, that can fail. So what we would do is the check. That throw at the end of it just means it can actually fail and crash your system, basically. Because you're asking for memory out of the system. So if buffer is equal to null, return false, isn't it? Yeah. See that we've already got it set up for error checking, so we'll do that. Alright, I'm happy with that. What else do we want now? Just to fill it. So instead of doing this while loop, we can now ask it to read the entire file. Come on, just get rid of this thing, thanks. Fread. We've got it, so let's file read the whole thing. And it's going to be buffer. Actually. Comma. I'll do it properly. I wish. Oh, it's just putting this up. Size T size. Well, that's just size of char. Bytes. We want to use bytes, so that's the size of. This is a standard way of just saying bytes, a char. because that's the type we're using. Number. So I've done size T size. Size T number will be num bytes or file length. Look, notice that I try and use English. And then it wants the stream, the file. So that's just file in. And that's it. Hold on. So that will read the entire file into the buffer. That's a nice one. Alright, we don't have the printout, so let's do the printout thingy. So let's see what they've used here. Yeah, %s buffer. Which is what I've used before. So they've just done the same as what I did before, but slightly differently. So it would be printf, open close semicolon, and it would be %string, comma, buffer. And this should do exactly the same as we did before, but there's a big difference. We now have it in a buffer. And that is an enormous difference. Alright, let's try and terminal run build task. Let's see the errors. Current line, unused variable. Yeah, we're not using it anymore. Okay, that's a fair shout. That's okay. Right, are we ready? Are we ready for F5? Will this do exactly the same as it did before? I think there's something going on with the windowing system on here. Let's have a look. Nope. It's not giving us anything. Is it getting to there? Return. File length is 2,451 bytes. Really? Bing. Let's have normal, please. Projects. Sandbox. Main. 2,451 bytes. So that's correct. Buffer. File length. Yeah. The buffer holds 0. Oh, we haven't done the fread yet. Step. Nothing comes out on the screen. Interesting. Okay. Let's go to you. Not happy. Not happy bunny, that's not doing what I want it to. Contents. \n. Comma S. Okay. Contents of the buffer equal nothing. Yeah, that's what I thought. Right, so let's look this up now. We have an allocation, a C alloc. Allocates and 0 initialize array. Allocates a block of memory for an array of num elements. Well, num elements was correct. Where's our alloc? C alloc is there. So I can F5 to there. Right. File length equals the correct value. We've decided. So we've placed that first. Allocates a block of memory for an array, number and size. Num elements, each of them size bytes long. Alright, depends whether you're on a 32-bit or 64-bit machine, I suppose, so we put the size of a char. Yeah, I can understand that. So it becomes platform independent. So I agree with it. It's not giving me any hover information. Like it tells me that's 2478. Now I know the size of a char is 4 bytes. But it might not be on this side. Okay. That's interesting. Alright. So I don't think we're doing this wrong. Data race is not I don't care. See also free malloc and realloc. No, I won't. C++, forget it. C alloc is the C variant of memory, well, malloc. That's all it is. Different variations. I'm still wanting to do the scanf thingy, really. I don't think we're reading the file. I don't think fread is doing what I'm thinking it's doing. We didn't reset the pointer. Hold on a minute, we've done something wrong here. All we've done is we've read in the end of the file. There, reset the file position indicator to the beginning of the file, otherwise it ain't gonna plummet there. Dumbo. I am stupid. So what we've done is we've sent it to the end to find the file length. Then we've allocated memory for the file length, but we never reset the goddamn thing. Is it just fseek? It'll be fseek again, won't it? Yeah. That's the fseek I want to look up as well. Okay. So it would be fseek, open brackets, close brackets, semicolon, and we are going to put in file in, 0 length, and I want seek set, I think it is. Yeah. So reset it to the front of the file. Now it should work. Stop. Save. F5. Press return. Crashes. Oh no, it doesn't. Continue. It worked. Take the breakpoint out. Woohoo! So we've got the same program, but there's a big difference with our program now. We've extended it to use a buffer instead of just a while loop printing it out, and we're reading the whole file in at once, and we can print the contents of the buffer. So if I try, this is a test, for instance, we will get this. I'll still do the command line arguments, we haven't changed anything there, and we will still get the whole file. There's nothing at the end here, okay? Did I do it or not? Yes. I've got a blank line here. Notice it's not there. And there's a big, please notice this, there's a big reason for it, which I'm not going to explain unless you ask me to explain. Which is why I always have a blank line at the end of all of my files. And I always have a blank line at the start of all of my files in case the same thing happens but in reverse. It's how files are stored on different systems and how they behave. So contents of buffer equals, and there is that blank line, you see. So the blank line does exist, and at the bottom the blank line doesn't. So on this system, it's used my bottom line here to store some information. That line has been used by the Linux system to store some information about the file. And if you didn't know that happened, you do now, because you've got it in front of you, the evidence. I'm not going to tell you what that information is, but I do know what it is. Right. Lovely. Let's just I want to just quickly check something, because we've now put another include into our file. I want to see what it's done to the size of our file. And we need to talk about it. Yeah, I thought so. Before putting that include in, we were at 16 kilobytes. We are now up to 22 kilobytes because we've added an extra include. Every time you add an include, you add the contents of that file to your program. And the contents of those files, as you can see, are quite big. This is shown by looking at, you know, going back to our original stuff here. This is shown by what's in that file. All of this stuff is in that file. So that's 16K. And if we look at this one, all of these functions take up around about 6K. Yeah. And in my world, that's huge. In today's world of gigabyte programs, it's a drop in the ocean. But, and this is another big but, warning, rant may happen. Oh God, have I got anything in here? Yeah, that's lucky. Last one. Let's talk about this size thing, because our program is going to grow in size. We have written 2K of text. Not even that, really. If I was to compress it all down into single line commands and everything, we haven't even written 1K of text. We haven't written... We might have written 1024 characters. Alright, we'll call it 2K. We've written about 2K of text. So we can take 2 off that. Before we were at 16, so this extra file is about 4 kilobytes. That's okay, that's not bad. But you've got to understand, every time you put that word include in, and you include somebody else's files or your own files, what the compiler does is it takes that file and it pastes it in at line, well, stdio.h gets pasted at line 21. Zoom, wherever stdlib.h ends up down there, that gets pasted in next. And then it comes to our function, and of course at the very end is main. You've got to be aware of that. That's all the include does. It just says, hey, copy and paste that header file into here. Now, brings us to making our own library in a bit, yeah, because this is now becoming usable. There is a problem with it, and it's because I can't work out how to exit a program without crashing it. So that's the next thing we have to do. Remember, I'm going off a 30-year-old memory here, and I'm on drugs for pain, so I can't remember much. It's going to be interesting to see if we can make this into a fully fledged reader file, or reader text file as we've called it. Because now it's reading a text file and it's giving us back true or false. Did it read that file? But that's not what we want. We want it to read the file and give us the file back. So we want the type of buffer. Here's our buffer, it's a char star. So we put in char star. Now we're going to get errors because we can't return that. What we can do though is we can return a null. So we can get around it this way a little bit. Again. So if I'm going to do that, they're already null, but yeah, I think we better return at that point. Otherwise it could crash at this point. All that's doing is saying if the buffer didn't create itself, then return null. So what we can do, instead of checking for this, what we can do is we can have something that goes along char star file underscore read equals cut, paste, semicolon. Okay. And now we can actually look at file read. And we can make that null. There you go. The other thing we can do, which is interesting, is we can now stop printing it out in here, because that's going to be absolutely no good to us. All we want this function to do is read a file. We don't want it to print it, so we can cut that out. Now it's starting to become very useful, this file. And we'll have a look at why. So that reads the file, and that just prints it out. Okay, it's not buffer now, it's file read. And that should give us exactly the same. Alright, save, F5, oops, return true still in there, abort at line 81. Of course. It would help if we return the buffer that we've read back. So thank you for catching that. Okay, return. There it is. It works as planned. There you go. Exactly the same as before. But check it. Contents of the buffer are missing a line, and at the bottom make sure it hasn't added a line. It's very important. And it hasn't added a line. Good. Thank you. It means it's useful. We can use that. Right, so ignoring the main function now for a little bit, I want to know what the fseek is. There it is. I want to know what you're doing, matey. Long int offset. Oh, God. Thank you. That's your offset. So, file stream, offset, and yeah, position indicator, yeah. So that's what it is, offset. You can actually use an offset in this, that's fantastic. I want to know that. Position to go to, so seek end is the end Actually, no, I'll put it in. Go to end of file. Set is go to start of file. Okay, we've got the allocating of the memory. We now know how that works for future reference. Fread. Is read all of file from current position. That's what that says, and that can come back in a bit. Get it all on one screen for you. Why not? There we go. And that's why I write down the screen, not across. It's so I can put all of these lovely, lovely notes in. And as you can see, it can get sizable in notes. In fact, I usually end up with quite a lot of information on the right hand side. There's a guide on how to use stuff. This file is complete. Sorry, this function is now complete. This function does exactly what I want it to do. It reads a file and it returns a buffer or the file contents. So return the contents of the file. Which is a char star. And we can now use that in any program we want to. That is now generic. It requires those two things to work, which is unfortunate. So we can either keep this in our main file with our main file, or we can throw this into the library. Which I think might be a good idea. Yeah. Shall we try that? Shall we make this the first function of our fantastic library, our new language that we are writing so that we can write programs? Reading a text file is more useful than you think. Reading a whole text file is rather nice. We could have variations on this, or read a line from a text file. But I think read a text file is good enough for what I want anyway. Right, so what I'm going to do is I'm going to go to sandbox.lib and I'm going to go to our core directory here. A new file, and I'm going to call it text file utils. And it's going to be a header file. Interesting. I also want a text file utils .c file. There we go. That's that one. In the text file C, right? Let's first of all set these up, shall we? No, I want the extra line. Copy. In the header, I think I'm going to use Pragma. Have I got Pragma? Yes. Oh. Why is it underscored? It's not going to work. That's interesting. Qt Creator to the rescue. For the life of me, I can't remember the old style of header guards. Let's just go to Sandbox a minute. Sandbox. Add new. I just need the header file. Choose, call it tell me. Next. No. None. Finish. There they are. Just cut that. And paste it here a minute. Actually, that's okay. What did we call text file utils? So it's text file utils. Do we want to put underscores in there or not? No. Doesn't matter. As long as it's individual. This is called a header guard. It will stop the header being included twice within any program. What will happen is anything that we put in between here can only happen once, which is what we want. So that's use started. Just one sec. Yeah, it's not the 10th, it's the 11th today. Okay. So I only want down to there. God, this is taking me back. And the next line here should be hash include. And it's in the same directory, so it's going to be text Okay. Now in text file utilities, I am going to place the utility that we made. Cut. And paste. Alright, there it sits, quite happy. This though, here, we could make it static. No, let's just do it plain. This here, in our header file, we're just going to tell the compiler, that's all the header file. The header file does not get compiled. Please remember this. The header file just tells the compiler that this exists, because the header file is the one that we include, not the CPP file or the C file beneath it. Okay, so that's just going to tell our compiler that, hey, this exists. Because now we've got a problem in here that, whoa, nothing works. As you can see, there's loads of errors. Because we need to copy, well, I suppose I could move them in actually, it doesn't matter. I'll move them in for now. There we go. So we also put our includes in the header. Some people won't, they'll put it in the main. They will put it in here. Not sure that's a good idea. That gets rid of all the errors. That's saved now. That's finished. That's finished. All we have to do now... Okay, we don't want to do that. Terminal. Whoa, terminal. Run build task. Build library. It didn't work, by the way. If we try and use it right now, it won't work. Let's try and use it. Hash include. It's a library, so I use angle brackets. It was sand /core / that's the utilities that we've done. And now, of course, all our errors will go away. Or will they? They don't. That's awesome. Wait a minute, save it. Will he go away now? Remember, that just means copy and paste that header file in here and it's got the includes. Okay. stdio.h. No, stdio.h. Thank you. I'll have the right one, please. That clears up our errors. Still seem to have an error somewhere. I think that just means changed lines. Yeah, we deleted something there. Okay. No, that's looking okay. Now, theoretically, we've done everything we need now to use that file. We've built Sandbox Library and it's available to us. So let's try and build it. This should fail. Sandbox. There you go. Error. Terminal process terminated. It should be a linking error. Let's see if we can find that error. Build. Undefined reference to read a text file. So it didn't work. It doesn't seem to have added it to our library. Well, of course it hasn't. I haven't asked it to. And that's the problem. This is what I always forget to do. So build has gone red. Oh dear. Build here looks fine. But it isn't. Because in here, we have to tell what sources and headers are part of our library. Now, these two are just placeholders. Are we going to leave them in? Plus, I prefer my headers first. We haven't even altered that. C plus 20, please. Core can go away. We don't need you. Okay. Copy you over. So that's config plus debug or release. I want it in debug mode, please. And here, I'm just wondering whether to keep these or not. Nah, we'll get rid. We'll clear them out. So the source will be sand/core/text file utils.c. And here it'll be sand core and text file utils.h. Now when we build, hopefully we don't get any errors. Library. Fantastic. Our library is now in use. We don't need you anymore. We don't need you anymore. Don't need you anymore. Shouldn't need you anymore. And now we've activated our text file utilities and added it to our library and compiled it. So if I press F5, pre-launch task build sandbox terminated with exit code 2. Okay, but what this time? Undefined reference still. I wonder if we don't need the headers. Because this is C, not C++. Interesting. That was interesting. Okay, F5. Return. Works perfectly. You've just made me a very happy man. Wow. Wonder why it won't work from a header. Oh. Oh. 1 sec. 1 sec. C is different. C is the other way round. That's why the includes were here. C is totally the opposite of C++. Wow. You would take that out, although it does work. Okay, all the red bits come back. That goes in there. Red bits disappear, please. Thank you. You're done. That's interesting. I'm going to put guards on it anyway. I've just realised what I've done. C is different. This is a lot more basic a system. I will place you into here. There. And I will take you, because I'm using it as a header, we don't need this header at all. There we go. Do I need the header? I can always go and find it if I need it. In here. We'll just pop that there. To remind me not to use headers. Okay, will that compile? Yeah. Wow. Interesting. Back in main, yeah, we can just do that. Alright. That's interesting. I suppose it may be, yeah. I don't think it's actually using the static lib as a static lib. I just think I'm using it as a bundle of C files, which you really should store with Sandbox, not with a lib. That's rather interesting. I'm rather interested in this now, so what I'm going to do is I'm going to go to user include there's a lot of files in there, don't worry. There it is. There's your hash. Yeah. Include. Begin decals. There's a lot of hash defines in here. Extern. Yeah. So it's using them as extern. So where's printf? There's printf. Extern int printf. I wonder if that would work. Do they use the other includes in here? No, they don't. Of course they don't. They're using the extern command. I'm going to do some research on that. Because in C++ it's completely different, so I am going to pull that back out of the trash. What are we trying to do? I'm just messing around with C. Restore. There you go. I was just thinking, how do libraries work in C? Because C doesn't normally use header files, as far as I can see. On what are these? I would put this. And that would be test H. Yeah, that's there. That's in the C file. Yeah. That's what I'm thinking. So that would be paste. Take the header guards off here. Which I don't think I need. Put them on here. Oh, don't put them on there. Put them on here. It's a better place to put them. And we will need a footer. Change it to header. They're using extern. That's what they're doing. So if I include the header file now, oh right, you need preprocessor magic. Not often a fan of that. Don't like to complicate things. So change that to a header. And try and compile it, I suppose. There we go. Nope. So how do you access from the header? This is going to sound stupid, but how's about renaming this? Oh, wait a minute, I know what I didn't do. No, don't rename it just yet. Don't be hasty. Terminal. Pro. Put that back on. Run the build task on the library. There we go, that went through. Back in main. No. It can't get to it from the header file. So rename it. To a CPP file. Save, terminal, run build task, library. That works okay. Terminal, run build task, sandbox. That works fine. What's in my header file? Nothing. I don't even think I need the external because it's not an external. Okay. So run the program. Whoops, get back into here. Run my program. And it looks okay. Yeah, it works. Just call the file a CPP file. Why not? There's my main and contents of a buffer. So that's now in a buffer. Yeah, that's what I was thinking. That's why I didn't need it. Because it's not part of a class and I haven't called it static. So it's not going to replace within the code. It's just going to exist above the main file. And I wanted to make sure that it was going to copy it in the correct place. So now my main looks like that. That's good. I like that. Just call it a CPP file and it'll respond to it normally as in C++ stuff, the C system for that. Everything's written in C, by the way. So what we now have is a main with using our own library for doing this. Read a text file, which is not a C function, it's our function. So what I've been through this today from the start of the stream is taking a program, splitting out a function, then naming it read a text file, then making it useful by introducing the concept of a file name, and then made it more useful by returning a buffer file read. So as you can see, it's a char star read a text file, const char star file. So you even get help on it now. That's good. If the file read equals null, it's an error. We can prove that by just putting in that. I am going to take out those lines now. I've had enough of those. That was an example. I've had enough of that return thingy. So run it. There you go. Unable to load the file specified. So it works. Works fine. I can specify any file I want. That's the original. So the actual program itself hasn't changed. All I've been doing today is showing how you can restructure it, and I wanted to then show how to put it into a library. There you go. You see C++. C source and header for it. Then C++ needs extern C, yeah, for functions. Ah, is it? Got ya. Right. Okay, let's try that. Thank you. I've never built a C library in my life. I went on to C++ before I got around to making libraries. So, rename. I'm going to try this. This sounds good. Extern C. Yeah, it's to do with the name mangling. Yeah, I know that. Is it just in quotes? Like that? Does that look right to you? Ah, ooh. Gave me an error for a moment then. Yeah, that's what I'm thinking. I think it was in quotes when I remembered it, yeah. So that should now not name mangle and screw me over. Let me just compile it. Extern char, read a file, what we got? Expected identifier or bracket before the string constant. Ah. Okay. But you can't compile that as C code, so you need if-def C++ around it. Yeah, I've got the header guards in. I'm going to be honest with you, it doesn't matter to me. Because I am using C++ in parts of this anyway, because I'm going to be using overloaded functions. So really, this lot doesn't matter to me. I'll be honest, as long as I can get it to work, I don't care. To be quite honest with you, I'll just call it a C++. It's easier. It's easier to do that than it is to do all the messing around. Because I'm going to be using a bit of C++, but it's just not a lot. No, not that one. Library, please. Yeah, so that's fine now. F5. Yeah, that's fine. That works fine. Lovely. Let's get this stored. So in Standbox, moved our first function to the sandbox library. That's what I've done there. And in sandbox lib, compile, no. Well, I'm just going to put it in text file utils. That's all I really want. Oh, Muppet, please don't sneeze all over me. Can I have them? I need the mouse, by the way. You can't just move. Thank you. Cats. You've got to love them. There we go. All done. I think that's a reasonable solution to the problems. Just make it a C++ library, I guess. So that's that. What do we do next? Right. We can now load files. That's great, so we can leave that alone. Done. Complete. Right, next project. I don't know if you can link anything. I doubt you can in Twitch. Twitch gets a bit sensitive about it, not me. Send it to my inbox. Email address. There you go. Fraser.sharp@virginmedia.com. That's Twitch. I just use Twitch by default. I don't touch anything. I don't have anything fancy on the stream. I'm not interested in any of that. All I'm interested in is sharing code with people. People teaching me as I'm trying to help people as well with their stuff. So it's a bit of a share and share. I mean, I've been doing coding now for 45 years plus. So yeah. So I've been showing people how to use documentation really, and not being frightened of it. So I'm using the c++.com and just been referencing things like stdio.h and stuff like that to show them what's available, that kind of thing. So there's lots of things available. Yeah, it's probably default links. Too easy for somebody to accidentally click onto a virus or something, I guess. So just for safety of the users, I guess. Right. How to read a text file. Complete. Added to library. Okay, what do we want to do next? Cheers, mate. I want to have a look at that. Is it alright if I do that later, though? I want to have a look at that and see if I can gain anything from it. Because I've never done a library in C, I'll admit it. I've never needed to. When I was programming in C, it was literally ball and C, and I think it was version 1. If you want to go and look that up. And I think I was on DOS 3. Or was it DOS 4 by then, or 5? Can't remember. But we didn't have pretty windows, put it that way. You can still get ball and C, by the way. So if I wanted to do this as pure C, I could. I'd have the same results. It's just easier to do it this way. For me, anyway. Because with this, I've got control over, you know, like the size. Just to help you people read it. I'm on a 4K monitor. You might be on a phone. You know. Really? It is. Spell Fraser with an O-R. FRAZOR dot sharp, SHARP, at virgin, as in never had sex, media, as in things you can see, .com. I think I described that not wisely. Virgin, by the way, is obviously a very famous company. Richard Branson. Britain's first self-made entrepreneur, I suppose. Grief. He's actually not a bad lad. He's a good lad. Richard Branson. Or Dickie, as his friends call him. Hey, Dickie boy. He's a rather good lad. And he takes care of people. His customer service teams are brilliant. I've got to admit. And it's the reason why I'm with them. Not because I like the company, but because their customer service, for me, is fantastic. They do what I ask them to do. When they were offering people X amount of brilliant broadband, I phoned up and said, well, can I have it as well? I'm an existing customer. And they said, oh, well, we haven't got it for existing customers. And I said, well, just ask your manager. I bet you can. So they asked the manager, and there you go. I've got now broadband. I got the deal. And that's all you have to do. You just got to ask, that's all. They're not nasty about it. You don't have to be nasty about it either. You know, just because you didn't get a letter through your door saying it existed. So what? Right. So we can read text files. What else should we be able to do? We should be able to open a window. Because we're in a windowing system, aren't we? Okay. And this is a decision. Anything from chat? Any specifics that you want? Oh, I've got an error on my network saying that Twitch is buggered up again. Oh, we're still live, don't worry. Oh, and it's given me a new set of... Oh, I see. That's interesting. Right. I'll redo that bit because Twitch decided to do the 2000 error on everybody. So we had to refresh their browsers. They do that. Basket cases. Decide how to open a window. We have multiple choices. Again, it's whatever header file we want to use. I want to use a C header file. Have we got that? Oh, we have SDL2. We've got graphics, video frame buffer, mouse, keyboard, images, mixers for audio, networking, TrueType fonts, and a library. Let's have a look at this one. This is a C library, by the way. It's a library written in C. They've probably written their library better than I've just written mine. Oh, it's put me on Firefox. That's very handy. Wiki, forums, mailing list, about bleh. download? Not really, but I'll have a look at that page. And the one you want is the development libraries. These, if you're using Windows, Linux, we get it off our distro. Is it the wiki then? The documentation? Ah, here we go. Simple Direct Media Layer, SDL. Oh, let's have a look at tutorials. Start somewhere. There's a whole website full of them. Wow. Game programming. Hey, should we make a game in C? That could be interesting. Firefox stops social networking. Yes, good. Good for you, Firefox. Well done. Okay. Well, that's interesting. Where's the bloody manual for this? Did anybody notice a manual for this anyway? Oh. Introduction. And I know how to start it. It's SDL in it. But how do we link to it? Oh, great. It's all about getting and installing it. And wiki help. Right. Articles. Nope. Oh, it's on Gradle. Haha. Interesting. We'll close that. How do we link to SDL2? So SDL2, I will put some question marks after that. I like SDL, as it gives everything that we're going to need, really, I suppose. Pro. It's gonna be libs. Let's put libs in. And SDL2. No. Tag it with capital L, isn't it? SDL2 main. I think we need. Yeah. That's what I'm thinking. Is it just SDL2 or is it SDL2 main, or do I need both? GUI applications. I'd use something like Qt. Cute. I probably wouldn't use SDL for Windows GUI applications. I don't usually program those, but games I'm interested in. I like games. Let's also link against GL just in case I'm going to need it. That's OpenGL. On Windows, that would be OpenGL32.lib. Anything else I can think of? I mean, that'll give us a couple of libraries to work with. Let's have a look, see where we can go with that. So let's make sure saved. Terminal, just put a space in. Just want it to recompile. Save. Run build task, and we'll have sandbox. Yeah, I've got unused parameters now. Don't worry about that. Well, it's not using it yet, so... Ah, here we go. That's correct then. No errors. That's good. So it's working. SD. Ah, is it SDL.h or is it? Do we have to go into SDL2? I think we have to go into SDL2. Yeah. I think that's the one I want. Comment these out. Thank you. Welcome to the sandbox for C. And SDL2. There you go. It runs, it works. Right, so we need two commands. If I remember rightly, it's going to be SDL. Oh my god. Just realised it's all in capitals, isn't it, for SDL these days. SDL underscore init. Yeah, that'll do that. SDL underscore everything. There we go. Try that one. Hi, Seppi. Do you like propane? I'm on... I'm on enough painkillers to kill most people. So go on, what's propane? Do I like it? You tell me, Seppi. Oh dear. I'm inventing a whole new C program here, which I don't know what I'm doing. I think this returns something. Int. Oh, Propane the music band. Not heard of them. I haven't listened to music in over 10 years. Properly. I used to be a musician. Things happened which means I can't play my instruments anymore. I'm now disabled, literally. So I absolutely love music. It's just that I got very interested in programming and spend all my time programming now. Because I'm on air, I don't listen to much music because I'm usually broadcasting. But when I'm not broadcasting, yeah, I tap into Eve Radio from the Eve game, and I listen to the music put on there because it's mostly old 80s and 90s prog rock and stuff, which I like. But Propane, no, not heard them yet. Want to look up. I love all types of music. If success is not equal to SDL, okay, true, get used to it. I'm doing it the other way. Once a drunken now believer, all hail the great deceiver. Oh right, I do like them. I like them already. Good lyrics. Right, I'm not allowed to read the lyrics out any further though, because we're still on air. So if success is not equal to true, we are going to printf. Yeah, we've got printf, haven't we? Printf failed to init SDL2 and return 99. I'll do. Death metal. Oh yeah, please. I'll have some of that. I like that with my breakfast. Gets me ready for the day. Right, F5. The big one. This is the biggie. Have we got SDL2? Nope. Okay. Actually, might be that. Try that. No. No, we don't seem to have SDL in it. Include the right library. Yeah. Oh, what am I doing? What am I doing? Manjaro. How to link to SDL2. La 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 la. What do you link with? You're not linking with anything. All right. Minus L. Oh, it's not a capital. Bollocks. There you go. Failed to init SDL2. Okay. Failed to init SDL2. Nope. Oh my god, what is going on here? Is it the linker? There's something weird going on here. Abort. Main. Okay. That works. Try and run it. And it's failed to init. I don't think I've got this one right. Init SDL underscore init video. I'm not linking against anything else, just the video. F5. Nope. How do we initialize SDL2? Never had that problem before. Let's have a look. How to initialize SDL2. Okay. I don't want to have failed. So it's just SDL in it, you don't need anything in it. That could be an interesting idea. Well done. Save. Try it. Abort. Yeah, it certainly wants a flag in there. But it won't in it. Alright. Control V. How are we doing with brackets? Did I bring an extra bracket in? Nope. That's all legal code. It tried. What are you linking against, matey? It doesn't tell you. Well, that's good. Nope. Definitely not. It bombed out on the window. Am I using the right stuff? Nope. See, SDL Windows, right. God damn it, I hate it when I'm doing things right. And they don't work. Do I have an event loop? No, I've got a delay of 3000. Oh, it did work then. Yeah, there's no refresh on it, is there? Yeah, I think it seems to be working. That's a little bit weird. Whoa. Application sandbox is not responding to me. Pee off. Pee off. Yeah, okay. So, that's interesting. Maybe we do have what we need. Maybe we do. Okay. First attempt at an SDL window. Right. This could be interesting. Cover you. Looks good. Things seem to be working. How did I install SDL on Arch? Well, I use a program called Add and Remove. And it's got a little search function up here, and I just typed in SDL2. There you go. They're all there to install or remove. You need the lot, by the way, all the way down to down to lib32. Don't think there's anything else I need in here. No problem. No problem. Only thing to be aware of is SDL may come with it. So when you include it, make sure you go SDL2 / SDL.h, because you'll have multiple folders. No idea, I didn't look. I just chucked them on the machine and that was that. I don't really care. I just want it to work. Right, let's go through what I've done. Well, what somebody else has given us. We've got our printf, which I will take down to there. We are then getting a window, declaring a pointer. Okay, fair enough. It's not a pointer, it's a handle. Be careful with the word pointer here. Yeah, just need the core SDL package. The other SDL packages are for different things. Yes, correct. I want the other things though. So window, yeah. An SDL window, as undefined. Fair enough. Fair enough. Oh, they've already put it to OpenGL. Thank you. That's kind of them. Check that the window was successfully created. Okay, we'll do that. But is there a reason you did this with the printf? Bad form. Okay. That's better. Alright. The window is open. Blah-de-blah, blah-de-blah, blah-de-blah. Okay. Destroy the window. I'll keep the SDL delay. Right. This is where we program. So this is the main event loop, which I guess will need an SDL event. Style? Call it event. Why not? That seems legal. I want 2 loops. Well, hey, we're going to loop-to-loops. Wow, this sounds like a theme park I'm programming. Not C. Alright, so while not SDL underscore window event dot no yeah, I don't like using while true. I'll be honest with you. Window should close. Does anybody know the window closing reference? I've got destroy window already, yeah. But what's the window should close event? Those are just types of windows. Is there a search function on this goddamn thing? No. Blah 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 blah. Window event, maybe. Yeah, SDL poll event is what we're going to be looking for in a minute or two. How do we check if the window should close? Oh, right, I know what I'm doing now. Oh, God, this takes me back. Jesus. Bool. Running. Equals true. No, don't put it there. That's probably a bad place to put it. Let's put it down here. Right. While running. Let's do it in English, shall we? We want to poll the events, so it's SDL poll event, isn't it? So it's event equals SDL poll event Oh, it's an int. And you want your event inside. Okay. It's an int coming out of it. SDL true. Okay. Switch event. I can't remember how to do switches. Do I have to do switches? Or can I just not do if? I don't use switches ever. It's true. Yeah, you could allocate it to the stack, but it doesn't matter. It takes so little time, it's useless. Event type SDL quit. Thank you. If event is equal to SDL underscore quit. What do? We put running equals false. Or you could break, I suppose. Is it return or continue? From a while. Why is that equals sign bad? Dot type. Oh right, got you. Don't come up with now. Event is a variable. Yeah. Does it not have an extension? No. Does it have anything? No. I think you lot are right, so I'm going to put in type. Stuff Microsoft. Doesn't like it. Okay. SDL2 using C, the main event loop. Let's have a look at that. Ah, yeah, it's a pointer. I think you've beaten me to the answer. SDL in it. If what? These guys are nuts. Okay, well, let's have a look at this code. Window, yeah, render, blah, 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 event. Yeah, we've got that far. Oh, they're not doing that. Alright. So to make my code work, we take away a pointer, which I would prefer to take away the pointer than I would to put an arrow, but you're right. Now it is correct. Thank you. All we do is send in the address. The ampersand sign means address, if anybody doesn't know. If you do know, that's fine. There's our window. Now we can close it. It's working! Woohoo! How do we get a context on that? Window context on it for OpenGL? That's the next stage. Setting up OpenGL. Oh, before you continue. Really? 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 Hey, are you reading all of this like you lot? I hope you did. Hope you pause and read all of that. Okay. These using GLH, yes, that's good. Not happy about any of this load of rubbish. Come on, give us... How'd you get your context? There's no point in me putting gl.h in if I haven't got context. Okay. This is rubbish. I seem to be avoiding the question. Ah, setting up on Windows. Blah, 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 blah. Linker, yeah, blah, 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 yeah. Oh, thank you for all of this. Oh, brilliant. Well, no, I won't accept. Thank you, that's a lot of rubbish. Glue. My God. How long has it been since I've seen glue? Yeah. Ah, here we go. SDL GL create context on the window. How do we then use that? We then have to initialize glue. No, it's not. No, that's why I was looking for it. So we want SDL GL create context on the window. So that's our next step. So at this point, seriously, I think I better include OpenGL. So it's GL. Wait, that was a good guess. I'll have you. Yeah, what's GL context though? Should just be an int, I guess. So it comes down here. Alright. So, what we got? SDLGL create context. Okay, let's go with that. Why is... That's better. SDL GL create context on the window, which is, funnily enough, window. Magic, huh? There's the command that we were after. Now we have to decipher it. Gives an SDLGL context. Context. GFX. There we go. Right, we have a context. What do we need to do with our context? How do we initialize the GL functions? They're using glue. Who gives init GL? Glue glad GL 3W. I'm guessing glue. That's the normal. But who gives init GL? I've got init state. No, it's not in here then. We have to init glue. So that's what we're going to use. Hash include GL EW. Oh, don't. Not necessarily the worst of them. Oh. Didn't like that. It's C. And I know it's C. I know that glue was written in C, and I'm trying to only use things that are written in C, as all of the stuff that I'm writing is in C. So none of this is C++ that you're looking at. It's interesting, but I want to know how inflated the files become. Okay. We can't get a we can't init glue until the context is created, if I remember rightly. Or which way around are these? Yeah. I haven't even said which context to use. Have they done glue up here? This is a bit dodgy. I'll take you three. You make sense. I'm going to stay in this area of I'll take 3.3. I should do it. Do we do glue in it after the context? What do we need to do for glue in it? Come on. Where have they put it in here? Here it is. Right. What to put on this? These are just hints, by the way. They are not commands, as it were. But I would like 3.3, please. Oh god, they've done this stupid thing with all the spacing. Wish they wouldn't. Alright, let's add this lot properly in, so that I can read it. Jesus. There we go. Major version, minor version, profile, mask, core. Yes, it does. It's a hit. That's the hidden feature that somebody was thinking about earlier. Maybe yourself. That's what's done in the background. That the context make current is not needed in SDL. That is hidden in the background. That is true. It's unfortunate, but when teaching people about OpenGL, it's hard to explain what's going on because you can't see it. But this is how we do OpenGL. We initialize it, we set some hints, and we need to be able to gain access to the commands. The commands themselves are in your video driver. Now, what glue does is it goes to your video driver and maps all of those commands to an enum. And it's that enum that you use to issue the command. And it's written in a standard way so that everybody knows what the commands are. Yeah. So I've got our context. We need to initialize glue. I don't want experimental, thank you. And that's just glue in it. So I think we'll do it here. And I'll do it properly. If There it is. If glue in it is equal to what are they going to use here? GL true. No, glue OK. Oh my god. How am I supposed to remember the intricacies of every single language out there? God knows. Glue OK. And it's not equal to glue OK. GLEW. It stands for the Graphics Library Extension Wrangler, if you want to know what it stands for. Oh. Ouch. Sorry, that was a finger. Let's put it into a function at least. Right, so I've got glue open up. Do I need to add anything else to get hold of those? Just init GL. That's it. Init GL. It's not here. So what are they talking about? I wonder if they're using glue for that. Oh yeah, OpenGL extension, yes, yeah. What are you using glue for? GLU. Yeah. Could be. Yeah, it is. Success flag, bool, success true. GL, yeah, program create. Yeah, the loading shaders. Sorry. Ignore that line. It sounds like we've already got it. So can I type in now GL? Yes, I can. Clear cut. Yeah, we've got GL. We're fine. So that's all I need there. The only other thing I'm bothered about here is that there. That command there. Because that to me is part of enabling vsync is part of the setup to me. In my mind, I keep that with the setup of initializing OpenGL. So that looks good. So that makes it current. That means everything gets picked up in the correct way. We should get OpenGL 3.3, but we can test it. We can test it. Let's do a test. Printf. Oh, thank you, Muppet. That was very kind of you. What we'll do is we'll type out open GL version. In %s /n, comma, GL get string, GL version Thank you. That should do it. Right, let's try that. It's enough cobblers I've just typed in, so... Yikes! It didn't like that! Glue error. That's line 87. Okay. I want to know what other... Oh, don't. Don't you dare. Oh, it's going to do it, isn't it? Let's have a look at the error then. gl.h included before glue. God, why did I forget that? Jesus, that takes me back. Holy cobblers. The order of includes matter. What? Yes, folks, that is an error. I should really have looked. I would have noticed it. Yeah. Does SDL have an OpenGL.h? Really? Okay, we'll put SDL first then. I'm not going to use it yet, but I'm going to leave the gap there for a second. .3 NVIDIA, well done. It's found it. It closes properly. Yes, I didn't init glue. You are quite right. That will help if we do it. Alright, I think that's it. I think we are now OpenGL. Nope, we're not. Undefined reference to glue in it. Well, yeah, I suppose it is. You're quite right. It's just glue. It's in lowercase. What is it doing? Can I have my keyboard back, please? Microsoft, can I have my keyboard back, please? Thank you. GLEW. Thank you, that's all I wanted to do. God. Okay, let's try in capitals. GLEW. There you go. We've now got glue. Glue is a thing between us and the OpenGL driver. All those perfingering long lines of text that were coming up as errors, those are the functions on your graphics driver, in your graphics driver that it was looking up. All those errors. Yeah. We should now have full functions instead of just 1.0. We should have 3.3 now. Wow. So all we need to do really is set a clear color. GL. We should be able to use stuff from here. Clear color. And what shall we have? We can have, oh, we'll make it red. R, G, B, and alpha. We'll have it solid. I'll do that. That can go. We enabled VSync, didn't we? So my graphics card isn't just about to blow up, is it? That's why I enabled it. And we'll do GL clear. What shall we have? GL color. Oh god, color buffer. That one there. Bit. Fanny will usually tell you. I've got a GT670 in, which goes back to possibly pre-2000, and it doesn't have a fan. It's just got a heatsink on a chip. That's how old it is. The actual graphics board is about 2 inches square. Yeah. Hell. And look at the graphics we're getting. You don't need a modern graphics card, you know. That's all hype and bull. Context didn't like, and we're not getting an update refresh. That's because we haven't swapped buffers. Why didn't it like me GFX? One second. You got to see this to believe it. Let me just pull this up. Here we go. Yeah, I've got a Core i5 in. Yeah, great. A 2500K, so it's actually clockable. But I've set it to 330. It doesn't go any faster than that. I don't need it any faster than that. No, that doesn't tell me. I've got a GeForce GT 630. GeForce GT 630. There you go. That's what it looks like. There's no fan. That one's got a fan on it. I don't know why. Doesn't need it. That's what mine looks like. Mine's a hell of a lot smaller than half of these things. That's the right size, but it's just got a... There's no fan on it, it's just got a heatsink on it. It's actually got that heatsink there without the fan. Yeah, that's what mine looks like. It looks like that heatsink on a board of that size. And it's just stuck in there. And if you have a look at the number of pins, that tells you how old it is. It's 8-bit. Is that 8-bit or 32-bit? That's 32-bit. Yeah. NVIDIA GT60 still going today, good and strong, and will give you 3000 FPS plus. You know, it's like, pff. It runs, top speed is about 4500 FPS before it starts getting a little warm, shall we say. Everything's working. We're not getting the screen update. So between there and there, we need to do something with the screen. Is it a swap buffer? Okay, how do you update the screen, for God's sake? Is it just swap buffers? It changed in SDL2 to something different. I'm damn sure it did. It used to be swap buffers. Use VSync, yeah. Yeah. Generate program. Create the vertex shaders. Check the vertex, yeah. Else. This is actually a good tutorial. I might be using some of this, but not really. I'm lying. Else. Clear color VBO, IBO. Not using that. Return success, yeah. Shader logs. He's gone over OTT on that. Yeah, that's a straightforward. Bind the buffers. Where's your actual draw? Oh, it's there. He's drawing elements. So he's using an index buffer. That's fine. But he doesn't actually say how to draw. You might have drawn and made, but where's his swap buffer gone? Swap window. Okay. Thanks. So SDL underscore GL underscore swap window. And it wants the window. Okay. Good. I guess we should now have a red window. We do have a red window. I'm still getting an error. I believe it's an unused error. Yeah. Bugger. Why does it say it's unused? It's a hidden usage. This always irks me. We should check then. Alright. How does he get rid of his error? There's ways you can do it in C, and it's quite simple to do once you can find a way of doing it. Oh, we still didn't initialize OpenGL, did we? We didn't seem to need to. Ow. Does that mean you're getting hungry, little madam? Where is my lovely SDL? No. There we go, we've used it now. 99, I think. Why not? OpenGL context could not be created. Don't care about you lot. Close window. Looks better. Simple. Laptop battery says I should stop watching. No, don't. No. Tell your battery. It's all right. I'll let you go. Thank you for the help. Thank you very much for the help you've been giving. That's great. That's great stuff. Loved your input. Thank you. I think that's an alternate shift on this machine. Yeah, it is. There. Do that. Do that. And look at that. That's lovely. That's very lovely. That's very lovely now. All right. Oh gosh, another one's saying meow. What time are we on? You're still 15 minutes early, you lot. Okay, I think we're going to go into general questions and answers session. I've been working with SDL for quite a bit today. Haven't really stopped. But we do have, now it should be an F5 works. Wow. There we go. We've got our SDL2 window. That's OpenGL window as well. That's amazing. That's great stuff. We've got our own library, which has one function in it. Good day at the mill, I think. What we're going to say here. SDL OpenGL with a red window. Yay. That'll do. Go me. We have what can only be called a successful start. Not bad, eh? I could move this over a bit, actually. Looking at our window. So we'll relax into question times. If there's anybody left to ask for questions. Not doing any more programming as of now. But we have got OpenGL version 3.3. We've got a sandbox using C and SDL2. Everything that we are using is C, except in the library where we've used C++ to construct the library. But that's all. Everything in the library is still C. Don't worry about the C++ side effect there. It's just easy to do it that way. But I do have a message on my mail on how to do it properly in C. So I think we will be changing it over tomorrow. So then we will be pure C. With SDL, of course. Why not? That was a lot easier than expected. The program's got a bit bigger than it needs to be. That's the first thing. Programs that go beyond, let's say, not that bad actually, we're only at 155. And remember, I do space everything out. I'm not afraid to space things out, because then I've got this ability on the right hand side. Decide to open a window. Yeah. Done it. That's complete. Oh, wait a minute now. I'll leave it as it was, because I don't want to do another commit. So yeah, we've decided how to open a window. We have completed our first function, how to read text files. We can read any text file we want on the computer, and it will give us a buffer in return, a char star buffer. That's nice. Each line of text is separated by a \n, which is also nice because a few other functions depend upon it. So that's a big advantage. Everything's working rather nicely. How weird. So we started programming in C, and we have got a lot further than any other language I've been experimenting with for the last couple of weeks. That's interesting. And I'm using a text editor to do it. Not a very good text editor at that, but it's a text editor. Just as easiest for me to use on Arch, on Manjaro. I would be using Visual Studio 2019, I think is still out, if I was on Windows. But I am going to look into other things as well. See if there's anything easy. I don't want to use anything like code blocks and IDE unless it's properly written this time, but I don't think it is. It hasn't changed in all those years. They still don't realise it, I'm sorry, but we need a darker background for coding. We don't want to be staring at a white, bright screen all day. Simple things like that, just to save your eyes from going blind. You know, nice things. Mistrin was ace today. We even got to joke about my graphics card, which somebody thinks is amazing, if I remember from yesterday's stream. They thought I was amazing pulling 4,000 FPS. But anyway, not to worry. Right, the cats are looking at me silly. Everybody who's been on the stream today has been brilliant. We've had no trouble with bots and things. I don't think we have. We've had a good chat actually. Yeah, 2700K, yeah. More than fast. This CPU anyway. So yeah, I'd like you all to take care. Stay safe, don't get ill, and join us again for more. This will go up on, this is definitely going up on my channel. Take care, peeps. Now all I've got to do is find the off button. It's somewhere down here. Stop streaming, that's the one. Catch you tomorrow.